Hello, Physics Nation. My name is Nate Larmond, and this is spreadsheet video number 2 for human power output and heart rate as a function of time to do 20 chair step-ups. So I was building the data table. I had built a few of the columns based on sample calculation, and I think I now have all of the columns for each measurement and each calculation. So the weight of the person in pounds, mass in kilos, their force in newtons, the height of the chair in meters, the work for one lift, the work for two lifts, the time to do 20 lifts. Power is the ratio of work divided by time, or the joules per second, or the watts. And finally, heart rate. Heart rate in beats per 10 seconds, and then heart rate in beats per minute. So the whole point of the sample calculation is to translate this into a series of columns, and we're going to enter all of the data into this table. You can see the formatting is a mess. I just went A4, typed the variable. Pace is a qualitative variable, so it doesn't have any units in parentheses. You could just say slow, medium, or fast. All the other data are quantitative. Okay, but like I said, the formatting's a mess. You could go in and change the column width of each of these, but that'd make our table really, really wide. So I like to wrap text. I think I did this in the last video. Let's wrap this text, and now we can come in slow, medium, and fast. Yeah, I don't like that. It's qualitative, so like I said, it doesn't really need units in parentheses. All right, now we can just go in and, oh, that's fixing the column width based on the title of the table. So we don't want that. We're going to auto fit that. All right, now I think we can double click. So we're just going to try to squish this. The font's really big. Let's see here. That looks better. Don't sweat this too much, because when you paste it into the doc, the formatting gets messed up anyway. So you're going to have to do this little adjustment thing even after you paste it into the doc. And that looks good. And there you go. Good enough. Okay, so let's actually enter some data. I think Sid's first set was slow. It took him 54 seconds. He weighs 68 pounds. Let's see, how many kilos is Sid? So you do pounds divided by 2.205. Okay, so Sid's mass is 31 kilos. We can chop those significant figures with this guy. I think that's good. How do you find Sid's weight in newtons? Well, equals, click on the pounds, and we're going to multiply by 4.45 pounds per newton. Sid weighs about 300 newtons. The chair was 0.48, 0.48 meters, roughly half a meter. And here's our first calculation. Work equals force times distance. So we have to do newtons multiplied by meters. All right, one lift was about 150 joules, except he lifted himself 20 times. So you do that work multiplied by 20. And now we're going to calculate his power. Whoops. Power is the rate that you do work. So we're going to do equals total work divided by elapsed time, 54 seconds. Sid was putting out about 54 watts, which, like I said, is a really weird coincidence. His heart rate was 20 beats in 10 seconds, and all you do is take that and multiply by 6 to get his beats per minute. All right, so there are all the calculated values. Oh, there's a way, hang on. Is it view? Show formulas. Right, so this is sometimes useful. Can you see all of these formulas? Yeah, let me stretch this out a little bit. Yeah, so if you go to view and show formulas, it'll show you each one of these. Alrighty, enjoy your spreadsheet construction. I'll come back and do the graph.